Welcome to ISIHO 442, Study Session 2, Linear Programming, Graphical Method. Introduction. Linear programming is a mathematical technique concerned with allocation of scarce resources. It is a procedure to optimize the value of objective, e.g., maximum profit or minimum cost, when the factors involved, e.g., labor or machine hours, are subject to some constraints, e.g., only 1,000 labor hours are available per week. In this lecture, you will learn how to formulate linear programming problem and how to obtain the solution through the graphical approach. Objective. At the end of this lecture, you should be able to formulate a linear programming problems in a standardized manner and be able to obtain the solution using the graphical method. A. Conditions for using linear programming. The following conditions must be satisfied before a linear programming procedure can be applied. The problem must be capable of being stated in numeric terms. All factors involved in the problem must have linear relationships. The problem must permit a choice or choices between alternative courses of action. There must be one or more restrictions on the factors involved. B. Steps in formulating a linear programming model. Before attempting to solve any linear programming problem, it should be formulated in a standard format. The steps in the process are to decide upon the objective, calculate the contribution per unit for maximizing or the cost per unit for minimizing, ignoring fixed cost in both circumstances. State the objective function, noting how many unknowns or decision variables appear. Consider what factors limit or constrain the qualities to be produced or purchased. State these factors mathematically and ensure that you use the correct inequalities, less or greater than. Ensure that all the relationships established are linear or can be reasonably approximated by a linear function. Solve the problem by either drawing of graphs or use of simplex method. Note that you can only use graphical method for problems with only two unknowns or two decision variables. C. Graphical method. The steps involved in using graphical method to obtain solution of a linear programming problem are as follows. Step 1. Formulation of the linear programming model in the standardized manner. Step 2. Determine the relevant coordinate for drawing the restrictions, constraints. You will need to work through restrictions that involve both unknowns, while coordinates of those that involve only one unknown can be deduced directly. Step 3. Draw the axes of the graph which represent the unknowns. You will determine the appropriate scale of the axis by the maximum value of each coordinate in step 2. Step 4. Draw each limitation as a separate line on the graph. Step 5. Use the inequality signs to determine the feasible region. Step 6. Determine the different possible solution points as defined by the feasible region. Step 7. Determine the optimum solution out of all the possible solutions in step 6 using the objective function. D. Binding constraints, limiting factors, scarce resources. These are the constraints represented by the lines of constraints that coincide with the optimum solution. All other constraints would be referred to as non-binding. E. Shadow prices, dual prices. It is an important management practice to value the scarce resources. These valuations are known as the dual prices or shadow prices. They are derived from the amount of the increase or decrease in contribution that would arise if one or more or one less unit of the scarce resource was available. Only a scarce resource can have a dual price. F. Example. Assuming you have a manufacturing company where you produce two products. Product 1 has a contribution of 3 naira per unit and product 2 has a contribution of 4 naira per unit. You wish to establish the weekly production plan that maximizes total contribution. Production data are as follows. F. Example. Because of a trade agreement, sales of product 1 are limited to a weekly maximum of 20 units, and to honor an agreement with an old established customer, at least 10 units of product 2 must be sold per week. Required: formulate the problem in a standard manner. Determine the relevant coordinates. Draw the axis of a reasonable scales. Draw lines of all constraints. Determine the feasible region. Determine all possible solutions. Identify the optimum solution. Identify the binding constraints. Determine the shadow prices of the binding constraints. G. Solution. Solution 1. To formulate the problem in a standardized manner, you need to identify the objective functions and all the constraints. For this particular question, can you guess the objective? It is to maximize, take 3. It is to maximize total contribution from the production of both products, given that product 1 has contribution of 3 naira per unit, while product 2 has contribution of 4 naira per unit. So, the total available labor hours is 180 hours, and you need to use 4 hours on 1 unit of product 1 and use 6 hours on 1 unit of product 2. 3. You can only use up to 40 kilograms of materials with 1 kilogram per unit on each product. 4. You cannot produce assuming you only produce to sell. You need to produce at least 10 units of product 2. 6. Finally, You cannot produce negative quantity of any product. Non-negativity constraint. This constraint can be stated in standardized manner as follows, using A and B to represent product 1 and product 2 respectively. 4A plus 2B less than 100. 4A plus 6B less than 180. A plus B less than 40. A less than 20. B greater than 10. A greater than 0. Note the careful choice of inequalities. We use greater than or equal to when the constraint implied maximum, while we use less than or equal to when it implies minimum. Also, note that the non-negativity constraint is not relevant for B again, since we have constraints that B is greater than 10 and 10 is greater than 0. The linear programming problem can then be stated in a standardized manner as follows. Maximize 3A plus 4B subject to 4A plus 2B less than 100 machine hours constraint, 4A plus 6B less than 180 labor hours constraints, A plus B less than 40 materials constraints, A less than 20 product 1 sales constraints, B greater than 10 product 2 sales constraints, A greater than 0 non-negativity constraints. Solution 2. For this problem, there are 3 constraints that involve both unknowns A and B. These are machine, labor, and material constraints. To determine the relevant coordinates for each of them, you first turn the inequality sign to equality, e.g. 4A plus 2B equals to 100. You will equate A to 0 and solve for B, and then equate B to 0 and solve for A. Apply this to machine constraints. You can verify that when A equals to 0, B equals to 50, and when B equals to 0, A equals to 25. In terms of A, B, this yields 2 coordinates, 0, 50, and 25, 0. Using the same procedure for labor constraints yields 0, 30, and 45, 0. While material constraints yields 0, 40, and 40, 0. The relevant coordinates for all the constraints can be presented as follows. Constraint coordinates A, B, see table. Solution 3. Note that the maximum value on A axis would be 45, while that on B axis 50. A possible axis that can contain the problem is shown below. Solution 4. Line of each constraint is drawn below as illustration before they are finally combined as expected. H. Minimization problem. The graphical solution of minimization problem is similar to that of maximization problem. The only difference is that most of the inequality sign would be reversed, and this will also affect the identification of feasible region. All other procedure remains the same. Hi. The general form. The general form of the linear programming model can be summarized as follows. Summary. Linear programming is a mathematical technique concerned with the allocation of scarce resources. To formulate a linear programming problem, the problem should be in numeric terms and have linear relations. We should identify alternative actions, restrictions, objective, contribution, cost per unit, objective function, limiting factors, and the correct inequalities. The stages of obtaining linear programming solution by graph are: formulation of the problem, determine the relevant coordinates, drawing the axis and each limitation, identifying the feasible region, obtaining possible solution, and finally, the optimum solution. We can calculate shadow prices for all binding constraints. End of study session 2. Thanks for listening.